Hello, everyone. All right, so for 6C, this is going to be multiplying polynomials. So this is kind of day one of polynomials. So we're going to look at just kind of what polynomials are in general. So first off, a polynomial is just a sum or difference of monomials. So just to kind of put it in perspective, monomials are exactly one term, binomials are exactly two terms, and trinomials are exactly three terms. So a polynomial just kind of encompasses everything. So we could be looking at monomials, binomials, trinomials, or just an all-encompassing polynomial. So just something to keep in mind, what distinguishes a term is addition and subtraction. So if there's no addition or subtraction, then it's going to be a monomial. However, if you look at binomials, they're only going to have one addition or subtraction sign. So I can actually change this to minus, and it's still a binomial. All right, now if I look at a trinomial, we have three terms, which are separated by addition or subtraction. All right, so for example, if I look at the binomials, I have my first term here, second term here. I have my first term here, second term here, first term here, second term here. If I look at a trinomial, I have my first term, second term, and my third term. First term, second term, third term. First term, second term, third term. All right. So an all-encompassing title or name for all of these is a polynomial. All right. So we're going to be more focusing specifically on multiplying them. So actually back in unit 1, when we did combining like terms in the distributive property, that was actually adding and subtracting polynomials. So now we're going to focus on multiplying them. In 6D, we're going to divide them. So we actually already did half of the polynomial lesson. You may not realize it. All right, so just to kind of refresh it, we're going to go back to the distributive property. So I'm going to distribute this 3 to everything inside the parentheses. So I'm going to have 3x plus 3 times 4, which gives you 12. All right, now if I look over here, now I'm going to distribute this negative 2. All right, so I'm going to have negative 2xy plus 2z. Because if you remember, negative times a negative gives you a positive. And then negative 2 times positive 3, which gives you negative 6. So we're multiplying the outside value times every term on the inside. All right, so now we're going to multiply a monomial, so just a single term. So I have x times 3x squared minus 4x plus 5. It's essentially the same as the distributive property, but now we're going to kind of bring in the exponent rules. Because used to, what we would do is we would only multiply by a number or a value, but now that we did the exponent rules, now we can also distribute variables. All right, so we're going to kind of start off step 1. So just distributing an x. So if I distribute an x, we're going to be multiplying. All right, so I'm going to have 3x squared times x, which gives you 3x cubed. And then 4x times x gives you negative 4x squared. And then x plus x times 5 gives you 5x. All right, so we're just doing product property here. We're adding the exponents. All right, now over here, same idea, but instead of just a variable, now we have a constant and a variable. All right, so I'm going to distribute 3n times 2n squared times 8n and negative 1. So I'm going to do 3n times 2n squared. So 3 times 2, which gives you 6. Then n times n squared gives you n cubed. And then 3n times 8n gives you 24n squared. And then 3n times negative 1 is minus 3n. All right, so this is really just kind of doing the distributive property and kind of stepping it up a notch. All right, so when we're multiplying polynomials, when you're multiplying, it won't always be a monomial times a polynomial. Sometimes it may be a binomial times a binomial, or a binomial times a trinomial, or you may even have a trinomial times a trinomial. Some of these multiplication problems can get very extensive very quickly, just kind of like the exponents. So the most common form of polynomial multiplication that we're going to see is a binomial times a binomial. So there's a method that we call FOIL, which we use to actually multiply these out. So there's two methods. First one's FOIL, and the next one's a box method. So with FOIL, we're looking at the first term, the outside term, the inside terms, and the last terms. All right. So I broke these first two problems down step by step so you can see exactly the layout of how these would be solved. All right. So when I say the first terms, we're looking at the first terms of both binomials. So I would do x times x. So this would be FOIL, not FOIL, F. Then for your O, which means the outside, you're looking at the far left and the far right, the outer terms. So this would be the outer terms, so O. And now looking for I, we're looking at the inside terms, so the two innermost terms here. Oh my gosh, this happens every time. There we go. So this would be I. And our last terms, which are the second terms of both. So if you kind of notice, this is really similar to the distributive property. I'm taking the first term and distributing it to both terms. Then I take the second term and I distribute it to both terms. So you can think of it as a double distribution if you'd like. So another name for FOIL is actually double distribution. All right, so FOIL is in blue. Nope, F is in blue. So that is x times x, which is x squared. Now for O, your outside terms, that's in red, so x times 5, which is 5x. And then we have our inside terms, which is 4 times x in green. And we have our last term, which is 4 times 5, which is 20. So once you get all 4 of those different term values, then you want to add all the terms together and simplify. So this is also combining like terms. All right, so I'm going to take all those and add them together. So I'm going to have x squared plus 5x plus my inside term, which was 4x, plus the last terms, which was 20. So I'm taking all of those products and just adding them together. So from here, I'm going to combine like terms. So my like terms are going to be the values in the middle. So 5x and 4x. So remember, for something to be a like term, it has to have the same base and the same exponent. So our base here is x, and our exponent here is 1. So those are the same, so I can combine those. All right, so I'm going to have x squared plus 9x plus 20. So this would be our final answer here. All right. So now we're going to look at the next one. So 2n plus 4 times 5n minus 3. So with this problem here, I'm still going to do first outer. Oh my gosh. Inside and last. Perfect. All right. So for your first terms here, those are in purple. So we're going to have 2n times 5n. So 2n parentheses 5n not parentheses, 2n times 5n. So it's going to be 10n squared. And now for the outer terms, so we're going to have 2n times negative 3, which gives you negative 6n. And then you're going to have your inside terms, which are 4 times 5n, which is going to give you 20n. And then your last terms, which give you 4 times negative 3, which is going to give you negative 12. All right, so just like before, then we want to add all these terms together. All right, so I'm going to have 10n squared and then minus 6n, then plus 20n, then minus 12. Oh my gosh, that's terrible. There we go. Close enough. All right, so just as mentioned before, we want to combine like terms. So it's going to be our two middle terms here. So we're going to have 10n squared plus 14n minus 12. So this right here is our final answer. All right. All right, so that's using the FOIL method. So the next method we're going to talk about is called the box method. Now the box method works for any polynomial multiplication. So FOIL is really limited and restricted to only doing a binomial times a binomial, but the box method works with any polynomial multiplication. So we could do a binomial times a trinomial. We could do a trinomial times a trinomial, or even like a 5-term polynomial times a 7-term polynomial, which I do not recommend. But either way, box method works for everything. And the box actually refers to the Punnett squares that you use in biology, especially for like genetics, when you're using like homozygous dominant, homozygous recessive, or heterozygous, or any of that stuff. So where it's the same Punnett square as before. All right. So we're just going to kind of go through the first one together. So this one, this is the model. This is how you're going to set it up. So I want to take both terms of the first binomial, and I'm going to put them across the column over here. So I have 2x and negative 1. So the first term and the second term. All right, and then for my next one, my second binomial, I have x and 5. So first term of the second binomial and second term of the second binomial. All right, so once you get your binomials set up here, to find the inside of the Punnett squares, you're going to actually go up and left, and that's what you're going to multiply. So for the top left box, I'm actually going to multiply. I'm going to do 2x times x, which is going to give me 2x squared. And then for my top right box, I'm going to do 5 times 2x, which gives me 10x. And I'm gonna, for my bottom left box here, I'm gonna have x times negative 1, which gives you negative x. And then for my bottom right box here, I'm gonna have 5 times negative 1, which is negative 5. All right, so same idea here. I wanna add all those terms in orange together. All right, so I'm gonna have 2x squared plus 10x minus x minus 5. So just as mentioned before, those middle terms here are going to be your like terms. So this is going to end up being 2x squared plus 9x minus 5. There we go. All right, so just another little note for you guys right here. So the diagonal from the top right to the bottom left boxes are typically like terms. So when we're multiplying binomials like this, they're going to be like terms. But it's when you start multiplying higher order degree polynomials times various degree polynomials, which that's going to be a lot for later on. But what I mean by the diagonal is these right here. So 10x and negative x, the diagonal from the top right to the bottom left, those are your like terms. All right. So whenever you're doing binomial multiplication, you can do FOIL or box method. It doesn't matter which method you choose. If you prefer FOIL, go for it. If you prefer box method, go for it. You do whatever you're more comfortable solving. Just remember, FOIL only works for a binomial times a binomial. So FOIL may not always work for your problems. All right, so for this first problem here, I'm gonna go ahead and just do FOIL. I'm gonna do a mix of both. All right, so I'm gonna do the first terms times the outer terms. I'm gonna try to. My Apple Pencil will let me. This is rude. Oh my gosh. Okay, so the outside, that arch is going way up there. All right, and then the inside terms and the outside terms. All right, so your first terms, so f, it's going to be x times x, which is x squared. Then your outside terms, which is going to be x times 2, which is 2x. Then your inside values, which is 4 times x, which gives you 4x. And your last terms, which are 4 times 2, which gives you 8. And then you can just add all those values together. So x squared plus 2x plus 4x plus 8. Combine your like terms. So x squared plus 6x plus 8. All right, so that's when I don't color code. So let's do this. Terms. And the last terms. There we go. Now it's color coded. Just so you can see where all the branches and whatnot are going to. All right, so that's using FOIL. And for number 2, I'll use the box method. All right, so draw myself a little box, or try to. Oh my gosh. Okay. Okay, so you can draw yourself a square, you can draw a rectangle, it really doesn't matter. Why am I such a perfectionist? I almost hate it. Oh. Hello? There we go. All right, so it actually doesn't matter which sides you write your first or second polynomial on, or binomial, it doesn't matter. So if you want to put the first one across the top, you can. Or if you want to put the first one across the side, you can. It doesn't matter where you put it. So I'm going to do 2m and negative 3 here. And then I'll do 4m and positive 2 down here. So remember, to get the inside, you're multiplying. So you're going to go up and left to determine what you're multiplying. So 2m times 4m gives you 8m squared. Then for your top right box, you're going to do negative 3 times 4m. So that's negative 12m. Then bottom left, you're going to do 2m times 2, which gives you 4m. And then for your bottom right box, you're going to do negative 3 times 2, which is going to give you -6. All right, now I want to compare the diagonal, because those are my like terms. All right, so my polynomial here is going to be 8m squared minus 12m plus 4m minus 6. So when I combine like terms, so 8m squared minus, I swear my brain just stopped working for a second. Everything's fine. All right. So 8m squared minus 8m minus 6. I don't know why I hesitated. Everything's fine. There we go. All right. So I will say this. If you want something that's a little bit quicker, I would definitely recommend using FOIL. If you want something that's more visually structured, so something that's more visually appealing for you, I would definitely recommend box method. If you want just a single method to practice and master, I would definitely recommend box method since it works for all of it. All right, so number 3, this one's super important. So because we just covered exponents, I know this might be a huge misconception. Before, when we did power rule, I told you guys to distribute the exponent. However, remember, anytime I told you to distribute, there is no addition or subtraction in the problem. Those were all technically monomials. So here we have a binomial. Because this is a binomial, you cannot distribute. So you have to expand. So I'm doing x minus 4 times x minus 4. So if I do FOIL, so F-O-I-L, so my first terms would be x times x. Second terms, or my outside terms would be x times -4. Then my inside terms would be -4 times x. And my last terms would be -4 times -4. So when you simplify and multiply, so x squared, -4x, -4x, and 16. So you want to add all those terms together. So x squared minus 4x minus 4x plus 16. So combine your like terms. So you're going to have x squared minus 8x plus 16. So really make sure that you expand here. Do not distribute the exponent. I know with power rule, it's going to be a little bit counterintuitive and a little bit backwards, but remember, those exponents that we did with power rule, those were all monomials. If it's a monomial, you can distribute, but if it's a binomial, trinomial, or polynomial, anything more than one term, you cannot distribute. All right, number 4. So I'm going to revert back to box method on this one. Just save you all the terrible agony of me drawing a box. Just going to copy it from the previous one. Okay, so I'm going to take my first polynomial or binomial and write it across the top. So k and 5. Then I'm going to take the second binomial and write it across the side. So k and -5. All right, so for my top left, I'm going to have k squared. Top right is 5k. Then bottom left is -5k. Then bottom right is -25. So notice here how when you combine your like terms, they actually zero out. So your polynomial here, you're going to have k squared plus 5k minus 5k minus 25. So this is going to be k squared minus 25. So your 5k and negative 5k here are going to zero out. All right. So down here, 5 and 6, these are the more tricky ones, but it's more specifically because they're more than binomials. So we have a trinomial times a binomial, which means you have to do box method. Because remember, FOIL will only work for a binomial times a binomial. And similarly over here, you have to do a trinomial times a trinomial. Okay. So you have to do box method. All right. So the great thing about box method is you can adjust the rows and columns. So because we have 3 terms and a trinomial, I'm going to give my box here 3 columns instead of 2. All right, so I'm going to do 1 column here, another column here. All right, and I'm going to split it down the middle so that I can give myself 2 rows. As I'll try to do. Okay. So I'm going to write my trinomial across the top. So I have 3c squared minus 6c plus 4. And across the left side, I will have 2c minus 1. So it's the same idea. You go up and left to figure out what the term's going to be. So for the top left, I'm going to have 6c cubed. Then in the middle, top middle, I'm going to have negative 12c squared. And then top right, I'm going to have 8c. Then in the bottom left, negative 3c squared. Then bottom middle, positive 6c. And bottom right, negative 4. So if you notice here, these diagonals are still like terms. All right, so I'm going to write it out. So 6c cubed minus 12c squared plus 8c minus 3c squared plus 6c minus 4. All right, so I'm going to combine the c squareds and then combine the c values. So when I do that, I'm going to have 6c cubed minus 15c squared plus 14c minus 4. So this will be our final answer here. Okay, so remember your Punnett squares or boxes here, they can be adjusted to fit the polynomial. They're much more flexible and adaptable to your problem than they are FOIL. All right. Now for number 6, now we have a trinomial times a trinomial. So once again, we have to do box method. All right. So we need 3 columns by 3 rows. Let's try to adjust it a smidge. All right, close enough. All right, so for across the top, once again, it's a 3 by 3, so it doesn't really matter which one you write across the top. So I'll do the k squared, 2k, negative 1. Then across the side over here, I will do k squared, negative 3k, and positive 4. All right, so I actually suggest you stop here and actually pause and actually try to fill this out on your own. See what you can do on your own. Or if you want to just keep watching, go for it. All right, so k to the 4th, 2k cubed, negative k squared, negative 3k cubed, negative 6k squared, 3k, 4k squared, 8k, and negative 4. All right, so these diagonals here are still like terms. My video went out for a second. All right, so now I'm going to write everything out. Let's do this. Those are here. All right, so I would suggest you write small right here. So k to the fourth plus 2k cubed minus k cubed minus 3k cubed minus 6k squared plus 3k plus 4k squared plus 8k minus 4. All right. So combine the 2k cubed, negative 3k cubed, combine negative k squared, negative 6k squared, and 4k squared. And I'm going to combine 3k and 8k. So most of this will be condensed when you combine like terms. So when we combine like terms, what we're going to get, we're going to start off with k to the fourth. All right, then when I combine 2k cubed and negative 3k cubed, I get negative k cubed, so negative 1k cubed. Then I'm going to combine all my k squared values. So I'm going to have a negative 1 minus 6, so negative 7k squared plus 4, so that'd be minus 3k squared. And then I'm going to combine my k values, so 3k plus 8k, which gives me 11k, and slap the negative 4 on the very end. So this would be our simplified expression right here. This monster right here. There we go.